It's a new problem. A car starting from rest. Suppose this is the line of journey of the car. It starts from point A, accelerates at a constant rate x for some time. So when starts from rest at t is equal to 0, v must be 0. This is v axis, velocity axis, this is time axis. And as time increases, as the body or the car accelerates, the velocity increases with time. So it is told a car starting from rest accelerates at a constant rate x. So acceleration is a acceleration is x for some time, after which it decelerates at a constant rate y. So suppose the body moves from this point to this point with acceleration. That means at this point, B point, the maximum velocity is maximum. So this is maximum velocity. That means if we show this in your graph, then maximum velocity will be this. This is maximum velocity. Okay. So this is V max, V maximum at a constant and decelerates at a constant rate to come to rest, and then again it decelerates. That means velocity becomes the velocity decelerate, velocity decreases, and ultimately the velocity becomes 0. So here at this point velocity again becomes 0. So it increases from 0 to some extent, that is V max, and then decelerates and becomes 0. Total time taken for the whole journey is t. So this time, this is 0 up to t. This is the total time. Find the maximum velocity of the car. You have to find out what is the maximum velocity of the car. So to solve this problem, it requires more time and more concentration from your corner. You have to determine the maximum velocity, and I shall help you to solve this problem. Suppose the time from this to this point is t1. If the total time of journey is 5 seconds, suppose, and if this is 2 seconds, the time of acceleration is equal to 2 seconds, then 5 minus 2 seconds is equal to 3 seconds, remaining 3 seconds for deceleration. So if t1 time taken to accelerate, then t minus t1, t is the total time, t minus t1 time will be taken by the car to decelerate and come to rest. So during acceleration, if this is the maximum velocity, so if m is suffix written lower script. If Vm is maximum velocity, then we have the formula V is equal to U plus a T. Here T means T1. T means T1. So this is T1. And in place of A, the acceleration is given. Acceleration is given x. So U plus x into T1. But the car starts from rest. That means initial velocity, this is equal to 0. So we can say then maximum then Vm is equal to U plus xt1. Here we must write, or Vm is equal to xt1. We have considered T1 is the time. Let us consider T1 is equal to time taken for accelerated motion. So Vm is equal to xt1. This is the equation. Similarly, at this point, the velocity is equal to Vm, and at this point, velocity is equal to 0. This is motion with deceleration. So we can write, so time taken for motion with deceleration is equal to t minus t1. So initial velocity during deceleration, initial velocity is equal to Vm, final velocity is equal to 0, deceleration is equal to y, and time is equal to t minus t1. So you have learned previously there is an equation governing velocity and acceleration during deceleration, the equation. Now I am reminding you the equation. Now according to formula, E is equal to U minus AT. Final velocity, initial velocity, acceleration or deceleration, here time. This is the formula, main formula. And in this main formula, we are writing different values. The final velocity is equal to 0 for this half only. Now forget about this half. Now this half, we are considering this half. So according to the formula, E is equal to U minus AT. 0 is equal to Vmax minus, in place of a y, in place of t, this is t minus t1. Okay. So this is second equation. And from second equation, we can write from this equation, or Vmax is equal to y into t minus t1. So this is first equation here. and this is second equation. This is second equation. Now we have two equations. Number one, this is the equation number one. This is equation number one. Equation number one, and this is equation number two. We have two equations. Now we write these two equations separately. Number one equation and number two equation in the next page. So we are taking another page. We have Vmax is equal to x into T1, and again Vmax is equal to y into T minus T1. Two equations are written again here. Now Vmax is this and Vmax is this. So this must be equal to this. Hence, x into T1 is equal to y into T minus T1, or x into T1 is equal to y into T minus y into T1, or x into T1. This comes to left hand side, y into T1 is equal to y into T, or T1 into, T1 taken common. T1 has been taken common, to x plus y is equal to y into T, or T1 is equal to y divided by x plus y. Now from first equation Vmax, hence Vmax means maximum velocity. Vmax means maximum So Vmax is equal to, we have the equation x into T1, x into T1 means this. T1 means y into T by x plus y. So Vmax is equal to this. So this is the answer of your question. And if you can't understand this from first watching, you must watch this for second time. It is a rather difficult problem for you. After going through the second video, this is the third video. And now I am giving you another problem to solve yourself. Number 3 page problem. Find the total distance traveled by the car during It's accelerated motion. Number one. Number two, find the total distance traveled by the car. By the car. Okay. During its decelerated motion. Number three, find the average velocity of the car. So these are three parts of the same problem. Solve yourself. If you can't, then contact me.